so all of you that are in the kitchen, like you, Ripley, I know you're ready. Get ready. Just be careful that you don't burn yourself on the comal or anything. And Dad, if you want to get the quesito out so we can make a quesadilla while we're at it, go for it. Archie, it's all yours. Take it away.
Okay, awesome. Thank you, Beto, Johnny, and Ronnie for great presentations. I want to emphasize a little bit of things. Okay, be careful because the comal or the hot griddle is going to be really hot. So make sure that you stand away from it. Make sure you have your parents or your brothers over there and an adult helping you out, because right here you see all this stuff. You might think it's food or it's stuff like that, but when we like to think about it, it's about science equipment. Okay, pretend like you're in the lab. The kitchen is your lab. Okay, so make sure. So a little bit about me. I'm a mechanical engineering major. Right now, I go to San Diego City College. It's a community college. I'm happy because I'm excited because I'm gonna graduate this coming up year. So thank you for me, and I'm hoping to transfer to a 4-year university. I'm excited. So let's go talk about the physics about it, okay? And I want to give a special thanks to my brother Jeffrey because he's behind the camera helping me out on this. Okay, so how Johnny was talking about the biology, about the corn, and then how Ronnie was talking about the chemistry here. If you were here live, if I could be there with you, this is how I will let you go ahead and give a piece of this masa, where you can go ahead and get it at your local tortilleria, and it has a pretty smooth consistency, like how Ronnie was talking about the gelatinous. Okay, so the question is about physics. We're gonna talk about pressure. Does anybody know about what pressure is? I cannot see you, but go ahead. Do you know what pressure is? I want to hear you get definition about pressure. Any volunteers?
You mean like peer pressure?
Just like pressure, like when you exert pressure, let's say, right here, I got this oil bottle, and when I say pressure, and when I'm squeezing it, kind of like that pressure, like the definition of that pressure. Or like when, let's say that this wall, I'm pushing on it, I'm exerting some pressure on it, but because the material of the wooden wall right here is so hard, so sturdy that my pressure is not strong enough. So when we talk about pressure, I'm gonna give you an example here of the masa. I roll it into a bowl. When we have pressure, your hand, my hand, is gonna be exerting some pressure onto the dough. Okay, so allowing it to squeeze the masa molecules all over the place. So what pressure in physics, the definition is, pressure is equal to the force that you're exerting over a designated area. For example, the force that I introduced was with the palm of my hand over an area of the dough. Okay, so think about that, okay? Because we're gonna go introduce you the machine that helped the tortilla lady or the tortilla man make tortillas. For example, I want to say, imagine me, and I have a relative, like a whole bunch of family siblings, let's say 20, and they ate 10 tortillas each. That will be a lot of tortillas that we'll have to make. My palms will get very tired of doing this for all those people. So what happened with engineering and innovation, somebody came up with this cool design, which is called a tortillero. Okay, so a tortillero just consists of a lever, and then you have another 2 plates that go in here, and then what the lever is doing is going to create a force to go ahead and squeeze the masa. And I'm going to show you how to do that. Okay, so come over here. So the first thing, because the masa is kind of sticky, if I go ahead and place it here and close it, it's gonna get sticky all over the place. So what you want to do is get a piece of bag and go ahead and cut it, like how I did here. Go ahead and cut it, so the masa doesn't stick into the wooden panels of here. And you might see tortilleros that are made out of metal, aluminum. So, but this was really good for me. Okay, so now the question that I want to ask, before I do the pressure demonstration, the ancient civilization came up with this cool recipe of masa, but how would they cook it, right? That's the question. I made it into a bowl. You think they're at home, if you add heat to this, spherical shape, you think it's gonna cook well? Anybody have a guess?
Ripley, go ahead and answer, Ripley.
So I think it wouldn't cook all the way through.
That is correct. You are correct. You're right because okay, so if you apply heat, you introduce heat to this spherical shape, it's not gonna cook all the way through. Okay, so no matter how much heat you apply, it's only gonna cook on the outside, on the surface. But when you kind of like open it in the inside, it's still gonna be raw. It's not gonna be cooked. So you are correct. So that was a question that ancient civilizations like the Mayas and the Aztecs had. Like, well, how come we're not doing it right? How come we're not cooking it right? So somebody came up with a really cool plan when they started using their hands to create the conical shape of the tortilla, right? So, for example, this is a tortilla from machinery, and it's not gonna come as pretty as this one, like ours, right? So now, if you see here, this is a much better shape, right? It's more thin. It's kind of like symmetrical. It's a circular shape. It went from a sphere to a circular shape, and now it's evenly. So now when we add heat through it, right, Ripley? Why when we add heat to it, now it's gonna cook evenly on both sides, and that's what we want, okay? So let's go ahead and start doing the demonstration. All right. So like I mentioned, you need this piece of bags right here so it won't stick. And then what you want to do, you want to come over here, Jeffrey, closer. You close this you close this panel first, and make sure that you close it all the kind of press on it with your hand, because if you press on this, sometimes it can get stuck and it's not gonna go. All right, so I'm gonna go ahead and do this one, and then I'm gonna go talk about the physics about it. Okay, so this is kind of like the process. You just press on it, and then let's see how it came out, and then you get this pretty cool shape. Okay, and that's how you get tortilla. But let's talk about while that one cooks, let's talk about the physics behind it. All right, so we have here the ball. We're covering this again so it won't stick to our tortillero. So we're closing it. We're closing this panel. So as you see, we have something like this, like an ice cream sandwich, kind of like an ice cream sandwich. So what's gonna happen? Let's see. What's gonna happen? I'm gonna exert a force down way this way, but at the same time, there's gonna be a force coming from the bottom up. So those forces are gonna meet each other over a surface area, which is gonna be kind of like, if you think about this part of the ball to be on like the North Pole, and the bottom part kind of like the South Pole. They're gonna meet there. So you're gonna have a pressure going down and a pressure going up, okay? And then what's gonna happen, they're gonna cancel each other. But because we have masa dough, we cannot just cancel it, right? We cannot just make this disappear and be magic, right? So what's gonna happen is that the masa molecules are gonna spread out because they don't have a way, they cannot go up or down. So they can only go to the sides. So that's the reason why the tortilla gets its circular shape, all right? So I'm gonna go ahead and do that. And then this lever right here is allowing me to facilitate, to make it easier on myself to make that force, okay? To create that force, to generate that greater force, because you can control the thickness of the tortilla. If I use a little bit of force, do you guys think it's gonna be thin, thick, or medium, right? So the more force I use, the thinner the tortilla is gonna be. So I'm gonna go ahead and put all my weight on it. All right. And like how we saw, the molecules of the masa spread out evenly, right? The force came right here in the middle, in the center. I'm gonna indent it right there. And then it kind of like push all the molecules of the masa outward, like this way.
So is that one like a donut tortilla, Archie?
No, I just make sure so you can see, so you can make it visible. But it could be thought about donut, but then because the molecules here kind of like it could generate a bag. You can kind of close it up. So that's the beauty about this masa, that everything, all the molecules, like in the chemistry part, they can come back and connect. Okay. So as this tortilla over here is cooking, now we're gonna talk about what happens. Like what happens? Why is the reason? Oh, my tortilla broke. And it's okay, it happens. I'm not a professional. I'm making tortillas, but it's okay. You see, so it's science. It's all working in the lab, okay? What I'm going to talk about here, I'm going to ask you something. Do you all over there like know why the reason your tortilla puffs up when you cook it, or have you seen that happen in your kitchen? Anybody? Have you seen your tortilla puff up? Thumbs up, thumbs down. It's okay. And if you haven't, you're probably gonna see it right now, okay? So bear with me. Sometimes in science, some processes happen really fast, like when you add catalysts, they happen really fast. Some other reactions happen very slow. So
you got a few thumbs up. So you have a few folks that have seen it. Ripley doesn't know. She kind of remembers vaguely. Right, Ripley? Is that what it was? Okay. So, but today you're going to show us. So go ahead, Archie. Keep telling us about it.
So, how you saw in the video, Ronnie, masa, right? So masa came with an alkali solution. When you say solution, it's something that's mixed with water. So this masa has water. So it has water. So this water is in the liquid state. So when you add the heat, it's gonna transfer into the gaseous phase. So what I'm doing here, I'm searing one side of the tortilla, the bottom part. In a way, I'm closing the pores from that side of the masa. And then when I flip it, I'm searing the other side like this. I'm searing, so now I'm kind of like making like an enclosement. So where I'm trapping everything that's inside. So what I'm trapping inside is all the liquid water that is being excited by the fire, by the heat, and converting it to the gaseous phase. And then what happens is that the gas, the pressure, the water vapor pressure that is being built is trying to find a way to escape. But because you trapped it, it cannot go anywhere. So that's the reason why it bubbles up, it puffs up, kind of like SpongeBob, right? Mrs. Puff, I think this is the name, Mrs. Puff, and where SpongeBob gets her really mad and she puffs up, kind of like that, okay? So that's kind of like tortilla what's happening. And then eventually your tortilla ruptures the hole, and then all the vapor escapes. So I'm trying to see if I can give you, this one kind of got stuck. I'm trying to see if it can puff up. If not, I'll make another one. But that's pretty much the science of that and the physics part. I'm trying to like put another tortilla in here. Bear with me. We're trying to get you to see that cool phenomena that I'm talking about.
Archie, if you push down on it with a spatula, it might help to speed the process along. It could be that your tortilla is a little thick.
Yeah, that too. If it's thick, it's going to take slower. So I'm going to put this to the side.
But I think after you make 100 tortillas, you'll be okay. You'll get better over time.
It takes practice. You're right. So let's see what's up with this one, okay? So how are you guys enjoying the science? The cool thing about this, like if we were live, you can make your own tortilla, and then at the end, the best part is that in this experiment, you can eat your product, okay? So it's really cool about the science of tortillas. You can make a quesadilla, like how Beto was saying. You can get some frijolitos, like here, I just fresh de la olla. Whatever you want, because everything really goes well with tortillas. So now let's pay attention to this one. Let's see. It's pretty hot in the kitchen.
I see the other ones bubbling up already, right? those there. If you push down on the spatula with those, they should bubble up. Yeah, keep it on there. Yeah, and as Archie's saying, usually, you know, we're all trying to figure this out virtually, so thank you for being patient with us. But, you know, if we were to be doing this with you in person, which we hope to do so soon, again, you know, we definitely would, you would be able to make your own tortillas there and eat them. And they taste phenomenal. They taste so much more better than store-bought tortillas, by the way.
Yes, Beto, thank you. I also want to add that in different countries, they also eat a lot of maize, right? They eat a lot of corn. I'm actually from Venezuela, and we use this process as well to get our own type of food. As you guys can see here, I see if you guys, I can show you pretty well. There it is. These are actually our brand. This is what we use in Venezuela to get our tortillas. We also have arepas that we cook from it. And this is how it looks.
Ronnie, can I stop you real quick? Because this tortilla's bubbling up right here, guys.
Yes. Yeah, go.
You see this right here? It's bubbling up. I'm going to try to lift it up. It's pretty hot. But you see? I'm going to leave it more there. But it does bubble up. You see? It's inflating right there. I don't know if you can see it.
That's amazing. That's amazing, and it looks hot, too. You know,
it's really hot.
old Mexican culture says that also that's a sign that when it puffs up, it's a sign that it's ready to eat.
That is true.
A ver, Archie, pégale una mordida. A ver si está o no.
Oh, yeah. You need some butter on that.
Oh, it's cold. Yeah. Well, there you have it.
Don't try that at home, kids. At least not without supervision. Ronnie, did you want to finish showing what you were sharing with us?
Sure. So yeah, I just want to show how it actually looks, the consistency of it. You see, it's actually it's dry. So that's what we use it after we do the nixtamalization process. We go and we dry it, and this is what we do to take it home and then cook it for ourselves. We put some more water so that we can get the actual masa that we want, that Archie was explaining. When you have the liquid water into the masa and then you cook it, then it goes to the gaseous phase, and then you get that bubbles in the tortilla.
Yeah, we're seeing one right now with Archie over there that he's showing that it's all inflado. So wow, really, really cool looking stuff. There's also, in addition to the one you shared with us, Ronnie, there's Maseca, right, which is a local brand that's used by a lot of folks. You can always make your own at home. And then there's flour tortillas, right, which is a little bit of a different process, but definitely, you know, a lot of the similar science. Not everything's the same, of course, but a lot of similar science. Archie, did you have any last words you wanted to share? It looks like you got the quesito and the aguacate coming out already too, right?
Yeah, I got an avocado tree just outside. I'm just gonna go there and pick one up and slice it and dice it.
It is lunchtime.
I mean, yeah, it's getting lunchtime. I don't have much of it. Yeah, it's getting lunchtime. I'm gonna be making here tortillas for the family. I wish I could be there with you so I could kind of like give you a sample of them, because like how Beto is, like, these are way better when you make them freshly from home with your hands. The store-bought ones, because of the manufacturer, they're still good, but not as best as a fresh one.
All right. Well, thank you, Archie, for sharing that. I appreciate it. Well, folks, that pretty much brings it to the end of our lesson for the science of tortillas. We wish that we would be able to spend the morning with you and make them in person so that you can have the full-fledged experience. But we trust that hopefully soon we'll be able to do that with you all. In the meantime, feel free to have parental supervision and make it a family project to go and do it. I can almost guarantee you that many of your parents have had the opportunity to do this in the past and weren't even aware that there was so much science going into it. So maybe this could be a project that you do together. You share about the science, they share good food, everybody's happy.